A warm welcome. This is Control Systems course, lecture 4.4, dealing with the design of the lag lead and lag lead compensator using body plots. While considering the lag compensator, first step is to determine the compensator gain K to meet the steady state error requirement. So in the problem itself or with the system, the steady state error will be given, or the velocity error constant will be given, kV value or ESS value, whatever may be, will be given, and we have to equate that with the compensator gain, and we can find out the value of K value first. Then we have to draw the Bode plot for the given system. From the Bode plot, we can calculate the phase value. So we know about the phase margin value, and then we can calculate the value for the angle. And next, what we have to do is we have to find out the value of beta and capital T. So what is the thing is, from the Bode plot, we infer a phase margin. Then we come to a conclusion whether this phase margin is correct or not based upon the phase margin given in the question. If suppose it doesn't match with the given phase margin, then what we have to do is we have to add a 5 degrees along with the angle, that is with the phase margin. New phase margin has to be considered. 5 degrees has to be added to that phase margin. It's a small adjustment. Now with this new phase margin, what we have to do is we have to go in reverse. We have to find out the gain crossover frequency for that new phase margin, and from that new gain crossover frequency we have to find out the gain value. What is the gain value? So with this gain crossover frequency, we can find out the T value. T is equal to 10 divided by omega D. So we can find out the T value, and then with the gain crossover frequency, we have to find out the magnitude value at which this gain crossover frequency occurs. So then we have to find out the beta value as per the equation given. 20 log beta is equal to 20 log K plus 20 log G of J omega at gain crossover frequency. So we know about K value, which we have already found out using the compensator gain, and from after that we now know about the magnitude value as well as the gain crossover frequency value, so that we can substitute both in that transfer function and we can find out beta value. In this manner, beta and T value can be obtained, and properly we can substitute that in the necessary design uh, of pole and zeros, and then we can find out whether the compensator system is providing a better response, that is whether the obtained phase margin from the compensator system is equal to the provided phase margin, I mean the stated phase margin, or not. The sin phi m value, this phi m will give the omega m value. This phi m is nothing but the phase value, and from the graph we can see what is the omega m corresponding to this phi m. With that omega m, you can calculate the T value. Omega m is equal to 1 by root of T into 1 by T into root of beta. So already beta value is equal to 1 by alpha value we would have found out. We can substitute here and find out T value. Finally, you get compensated design. T and alpha are known, so you just substitute T and alpha as well. Then you can check whether the compensator system is satisfying requirements or not. The form, I mean, we can bring this form. We can bring this, bring to this form, and then we can check whether the this compensator when included to the system, that is when the compensator system is satisfying the desired features, I mean the phase margins, etc. or not. That's all.